Greetings and welcome, friend. Right now we had a delay, hour and a half, and I just have one student in my classroom. But the entire internet can see this video if they want. I have not been banned in any countries as far as I know. So here we go. Question 14. Our goal is to factor the polynomial. Notice that the a, the number in front, the leading coefficient of my quadratic term, my second degree term, just getting us used to some of the vocabulario here, is not 1. And because that's not 1, I'm going to have to use what's called the AC method, unless I could have stolen GCF style from all three, but there's nothing common between all three that would help. So let's find the factors of AC, and 4 times -3 is -12, and so I'm going to find the factors of 12. And which of those factors subtract to be 4? All right, so because the AC is negative, I'm looking for the differences here instead of the sums. So 12 and 1 have a difference of 11, 2 and 6 have a difference of 4, 4 and 3 have a difference of 1. Looks like that's the one I wanted. So I'm going to split the b term into two like terms whose coefficients are the factors we just found. And so I'll have 4z squared with a 2z, that was a doozy, and a 6z minus 3. Right now, the people on the internet are like, that's got to be really awkward for the one kid in the room as Mr. Waddy's joking around. But that's fine. Here we go. I'm always on. Here we are, doing the math. Blah. Split the b term. Now, these terms have to multiply to be -12. So their signs are either going to be plus, minus, or minus plus, right? That's the only way you can multiply to get a negative. But they add to be +4, so that means the more influential, that is the 6, must have been the positive one, and there I go. So that was split the b term. That's the tricky step. And next, I factor by grouping. We got another student, internet friends. Life is getting better. All right, the math must go on. So I factor out the common factor between these two. Between 4 and 2, it's a 2. Between z squared and z, I could steal a z. My 2's and z's look similar, so I put the slash through the z. And between these two terms, between 6 and 3, I can steal a 3, and that's a plus sign, so I'm taking the plus sign with it. And so I'll have 2z outside a set of parentheses plus 3. This sign is important. Sometimes students write that, don't write that sign, and then it looks like multiplication, which is not the case. All right, so finding out what's inside these parentheses. 2 times what is 4? Well, that's 2. And z times what is z squared? Only one possibility. Oh, sorry, z, because z times z is z squared. And 2z times a 1z, actually a -1. I'm sorry, but my joke was too good. 2z times 1 is equal to -2z, -1, right? And let's see, 3 times what is 6z? Well, that would have been a 2z. And 3 times what is -3 minus 1? Remember that our sets of parentheses must match, and they do. So my factored form ends up being one of those duplicates, and then the 2 GCFs that I stole, right, which you can see here or there. So 2z minus 1 times 2z plus 3 is the factored form. I'm going to do a couple more of these. Here we go. So about this problem, before I start multiplying 18 times 18, I'm going to want to a yoink, and a yoink. I'm going to steal. I think the biggest thing that goes into 18, 15, and 18 is 3. And so I'm stealing a 3 from all of those. And that's going to make all my numbers smaller, thereby making my factoring easier. You technically can use the AC method and multiply 18 times 18 and find all those factors and find the ones that work and split the b term. But what happens is that you will end up with, in your answer, you would have been able to steal a GCF from one of your factors, which is perfectly legitimate, just so you know. But I like to take the easy way. So I'm going to factor the 3 out first. So 3 times what is 18? Or ask it this way, 18 divided by 3 is what? Anybody want to help me out? I've got 4 students now. This is great. 6. And I need that v squared there. And 3 times what is -15? Going to be negative 5, and that v is hanging out. And 3 times, well, we already said 6 was 18, and this one's got to be negative. So there we go. Now, the benefit of doing that is that 3 is now out of here, and I can now factor just the inside using the AC method, which is what I'm going to do. So find the factors of AC. So A and C is 6 times negative 6 is negative 36. So I'm going to find the factors of 36, being 1 and 36, 2 and 18, 3 and 12. Had to think about that one. 4 and 9, 6 and 6. Lots of them. In fact, 36 of the numbers up to 36 has the most factors of any number up to 36, just so you're aware. And because AC is negative, I'm trying to find which of these factors subtract to 5. I ignore the sign for now over there. So which of these subtract to be the B term? 1 and 36 have a difference of 35. 2 and 18 is 16. 12 and 3 is 9. So hopefully you guys are catching, your mistakes if you need to, or if you only made it partway through some of these problems, that's perfectly fine if you only got some of them done, because these are tricky, right? But I want to make sure you have enough to practice, because like I said, they're tricky. So let's see, difference of 5. Hey, the 4 and the 9. So let's split the B term into two like terms whose factors are the coefficients, or whose coefficients, my bad, are the factors we just found. This 3 is still way on the outside, so I'm going to have 6v squared. I guess I went square brackets too early, but that's fine. I'll have a 4v and a 9v and minus 6. And I've got to figure out the signage on these two terms. They multiply to be negative, so it's either plus or minus plus. And they add to be negative. So that means the more influential is negative. Who's more influential between 4 and 9? Anybody? Who's more influential? The 9. So the 9's got to be my negative and the 4's got to be my positive. That's the split the B term step. Now some of you are saying that we need more practice on the GCF part using the factor by grouping. And in order to do that, I'm going to steal the common factor between these first two terms, right? Terms are separated by plus or minus signs, and the GCF between these last two terms. So, ignoring this 3 over here for now, between the 6 and the 4, what's the biggest number that goes into 6 or 4? What's the largest number that goes into 6 or 4? 2. And between v squared and v, I can only steal a v to the first. Between 9 and 6, I could steal a 3. And tell you what, because this is negative, this has to take the minus sign with it. Must do. You'll catch your mistake on the next step if you forget it. And 3 is the biggest number that goes into both of those. This one had a v, but this one didn't. So I can't take a v with me. All right, so 3, still way outside. Like so. I'm going to have 2v outside a set of parentheses. I'll have minus 3 outside another set of parentheses. And now we're trying to figure out what goes in those parentheses. I'm going to have a sip of coffee. My youngest son, Rook, he's super into Chewbacca lately. He's got one of those robotic Chewbacca masks. And then Sunday in Wilmington, we were loading him up into the van, and he saw a lady that had furry trim on her winter coat hood, and he's like, Chewbacca, 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 and he thought Chewbacca was visiting Wilmington, Vermont, which very well could be the case. It's a great place to visit, but I'm glad the lady didn't find out that he was calling her Chewbacca. That I feel like women wouldn't want to be referred to as Chewbacca. I'm assuming. So let's see. 2v factored out. Now the question is, what goes here? 2v times what is 6v squared? 3, and v times v is a v squared, so I need a v in that one. And 2v times 2 would equal 4v. Now we're hoping for the same thing here, but don't just go assuming that it's going to be. But negative 3 times 3 is negative 9, because I already got the minus right here. Yep. Yeah. Yep. And -3 times a +2 would equal a -6. And hey, those match. So my factored form is going to have a 3 on the outside, right? That 3's just been hanging out this whole time, right? All the way down. By the way, it's super easy to forget that 3. That can be a point lost on a test, just so you're aware. Like, happens all the time to my algebra students. And in one of these parentheses, I'll write my duplicate, 3v plus 2, and in the other, I'll write the things that I factored out, the 2v minus 3. This is a beast mode problem right here. Like, this problem has so many parts to it. It's a good problem. It's if you can do this problem, you will be good for this whole chapter. All right, so it is tough. There's a lot of steps, though. Isn't it crazy how many steps there are? Oh, and each step is, like, difficult. Ah! He said my house has more steps than this. Speaking of puns intentionally, I had a violin pickup mic come in the mail yesterday, so I messaged a person who plays violin. And I said, hey, like, if even if you're not playing violin on Sunday, after the gathering, you could feel free to fiddle around with this. It's a violin mic, a violin, a fiddle. Come on, it also could work as a fiddle mic. It was such a good pun. I told my wife she wasn't that impressed either. That's okay. All right, last question. All right. Whew! We're already 11 minutes in. Okay, here's a solve problem. Now, in terms of solve problems, this is what we do. Step 1, set it equal to 0. That's done. Step 2, factor the left-hand side. We'll do that. And then step 3, use the zero product property to set each of those factors to 0 and solve. That is currently our only way to solve a second-degree equation, right? We're really good at solving. If this was just like -5k minus 18, we'd add 18 to both sides, divide by -5, right? We're good at that. But our only technique for solving these is through factoring right now. Next chapter, I'll show you some more. So the first thing I got to do, I can't GCF between 2, 5, and 18, so I'm going to multiply AC. So that's the 2, and the -18 multiplies to be, hey, -36. I just made those factors earlier. Watch this. Oh, no, I was going to screenshot the other ones, but they'll be different numbers. All right, 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6, all the time. All right. And because this multiplied to be negative, I want the factors that subtract to be 5. So 1 and 36, 35, 16, 9, and 5 and 0. 4 and 9. Wait, did they end up being the same ones as last one? What? The same. It's almost, yeah, it's similar. That's interesting. Yeah, and if these were 6s instead of 2 and 18, well, there you go. Let's see, split the b term into 2 like terms. So I'll have 2k squared. 4k splits into 4k and 9k, right? The coefficients of these two terms are literally these numbers. That's what I do with those numbers. Minus 18 equals 0 still there. Don't forget your equals 0. Don't do that. Let's see their signs. Can someone help me with the signs here? I've been explaining the signs forever. Could someone explain the signs? Well, they've got to multiply to be this, so it's either plus minus or minus plus. The AC. All right, they've got to multiply to be that number. That strategy works as long as your leading coefficient is always positive. Because you're right, if this is always positive, which we've always forced it to be, then you're right, this sign will always be the same as that sign. And so yeah, so you're looking here isn't that bad of an idea, like 95% of the time that'll work. As long as you made sure this was positive, that'll work. So they multiply to be negative, so their signs are plus minus or minus plus. And what do you think they're going to be because they have to add to be negative? What is it going to be? Plus minus or minus plus? How could I get these to add to be -5? Well, the more influential has to be negative. Right, so the 9 is the negative. And it's perfectly fine to do guess and check, right? If I said minus plus, I'd be like, okay, well, that would mean 9 minus 4, which would have been +5, and that's not what I... So literally, just do the guess and check mentally and just like, nope, that doesn't work, that doesn't work, that... And that's perfectly good. All right, let's make this video shorter. Here we go. Factor out the 2k, factor out a negative. That sign's going to come with it. 9. Wow, the whole 9 is coming with me there. And I'm just going to cruise in. So this is going to be k plus 2. And you can slow this down. You can pause this video later. You can look at this problem, right? Try to see if you could get these same values. -9 times k would be -9k, and -9 times +2 would be -18. Hey, the parentheses match, so therefore I'll have a k plus 2 and a 2k minus 9. Now, we've remembered to write equals 0 this whole time. Mandatory. Zero product property says if two things multiply to be 0, then what can I do? I can break them up into two cases. Either the first one was 0 or the second one was 0. And these two problems we could actually email to our past selves from like a couple months ago, and they could have done these ones, right? -2, -2. I don't know that. Well, they don't have all the kinks figured out of emailing your past self. What's weird is your past self can email your future self. Did you know that? Your past self can email your future self, but you can't email back. I like to think it's even possible for my past self to give my future self a high five if I swing one hand fast enough that my present self can't slow it down to stop it from hitting the other hand. That's my past self giving my future self a high five. Think about it. K equals 9/2, right? Which, by the way, is the same as 4.5 for you decimal fans out there. But so here's two answers. These answers both work in the original problem right here if I was to plug them in for K. All right, guys. These are, like I said, the toughest problems in Algebra 1. So even if you're like 70% there with this, that's amazing, and just keep kind of practicing the pieces you need. If you need to practice, write this GCF part, maybe I'll be able to create a packet of just parts where maybe step 3's already been done. You know, maybe I'll do that for you guys. All right, thanks for watching, internet friends. Bye-bye.